Hey everyone, this video is a tutorial on how to make this plot with individual data points, a curve fit, and binned data points with error bars. This plot is based on a larger plot from a paper recently published in the journal Science. The authors made the interesting finding that gene expression of a particular circadian rhythm marker changes throughout the day to different degrees depending on the tissue type. The brain showed smaller changes and the viscera showed larger changes. And that's interesting, but we're going to focus on how to make this plot. I think this is a useful tutorial because we will be plotting some common features, such as individual data points that are smaller and in the background, a fit line, and additional grouped data points with error bars. First, let's import matplotlib and numpy. And for this tutorial, we're going to generate synthetic data, so simulate some of the data that they found in that paper, rather than going through the whole analysis that they went through in generating that data. So we're going to pull x values from a uniform distribution from 0 to 24, that's for the 24 hours of the day, and then sort them as well, just to make it easier to keep track of where the data are. Next, we have to use some function to figure out what the y values should be based on those x values. That's part of the simulation. And these values should follow a mean of a sine wave. So I estimated the values of that sine wave from one of the plots in that paper. To generate some of the y values, we're going to pull from a normal distribution. And that normal distribution needs a mean and a standard deviation. And so we already have the mean from that sine fit function. And I found that the standard deviation of about 0.5 seems to work pretty well. So we can pull these values from a normal distribution from numpy, and then let's also plot to make sure that this actually worked. So what we can see from this plot is that we do get a rough shape of a sine wave with some spread in the data that looks pretty similar to what our reference figure showed. Now that we've simulated the data, let's review all the things we need to plot for this figure. So we need to plot the individual data points. We have those. We need to plot this fit curve. And since we generated the data from a sine wave, we can just plot that as our best fit sine wave. And we also need to plot these bins. And the way the authors did this binning is they took all of the data in 2-hour intervals and used that to generate an average value and a standard deviation value to plot. So let's work on generating those bins and the standard deviations. To make these bins, let's first start with a list of all the odd numbers from 1 to 23. Now these are the midpoints of the bins, and these are going to be the x values that we're going to plot against. We're going to use a for loop to populate two lists that correspond to the mean values of each bin and the standard deviations of each bin. In order to figure that out, we need to run through this for loop for I in bins, and in each bin we need to find the start index and the end index. The start index for the first bin is just 0, and the end index is going to be the first x value that exceeds I plus 1, which would be 2. And we can do that using the argmax function, which will give us the first time the x value is greater than 2. And at that index, we can append a new item to the bin vals list and the bin standard deviations list. And to set up the next iteration of the loop, we can just set the start index to the end index. And each time it goes through, it'll calculate a new end index and then set that again to the start index. What you might notice is that this will work up until we get to the last point, because by the last time we're not going to find an x value that's greater than 24. So for the last iteration, we need to do this a little bit differently and just set the end index equal to the last item in the list. And then we're finished with this for loop. Okay, we're finally ready to actually make our plot. So let's set up our plot using this plot.subplots function, which generates these two objects, fig and ax, and we're going to be plotting everything with that ax object. So let's first plot the individual points. You'll get this string of nonsense characters unless you include plot.show at the end, so let's add that in here too. And there are the points. Now we'll want to plot several things on top of this. So one thing we can do is make these points fall a little bit further into the background by changing their alpha value. And alpha corresponds to the opacity of those points. So a small alpha like 0.1 will make them slightly more transparent. Another advantage of using an alpha of 0.1 is that if you have multiple points that are overlapping with one another, those locations will show up a little bit darker than the other surrounding data points. Next, let's plot the binned points, and let's also make these data points a little bit larger. Let's give them a marker size of 15 so they stand out even stronger against all those smaller individual data points. We also need to give those bins error bars. We can do this using the ax.errorbar function, and we need to specify the location. So again, using the same x value and y value, And we use the y-er parameter to specify the size of those error bars. And here we'll use the standard deviations. When we plot this, you do see those error bars, but now all these points are connected. And what's actually happening is that error bar function is plotting the individual data points as well as plotting those error bars. So all we need to do to get rid of those lines is to change the format to none. And while we're at it, let's change the color to black and let's give them a little cap size. So we set the cap size to 3. And that looks a lot nicer. The last thing we need to plot is plot that sign fit function. And so what we can do is plot the xvals and just run that function directly on the xvals inside of this plotting function, and let's give it a blue line. And if you look closely here, you'll actually see that the sign fit function, that blue line, overlaps with some of the error bars, and I don't really like the way it's overlapping. And this is because matplotlib plots things in order, so it's plotting those sign fit values after plotting the error bars. So if we want to send that one layer backwards, all we need to do is copy and paste that sign fit function plot before we plot the bins. Okay, we've plotted everything we need to plot, so let's do a little formatting. First, we can add a grid. And this grid has made me realize that I don't like the x limits, right? It looks like the lowest x limit is below 0 and the greatest is around 25. And this should really go from 0 to 24. So let's specify the x limits using ax.setXlim with a list from 0 to 24. And of course we need to label the axes. So let's give the y label gene expression and the x label donor internal phase, which is, I think, is a fancy way of saying time of day. One thing I often find myself doing when using matplotlib is changing the font size. And it's really easy. All you need to do is type in this font size parameter when you're setting the x and y labels. And let's set it to 16 for now. And don't forget, we can also change the font size of those tick labels on the x and y axes. We use this function ax.tickparams, and we can tell it to do both axes, the major tick values. We don't have any minor tick values in this case. And we set the label size to, let's say, 12. And here's our final plot. We can see the individual data points, that fit function, and the binned data points with error bars. I hope you enjoyed this video. See you next time.